Our last part of linear equations is to take a look at a system of equations. A system of equations is when you have multiple linear equations. Our goal is to figure out what answer or solution works for both equations. The easy way to do this is graph them and figure out where they cross. The ordered pair where they cross is the solution, the answer, the one dot, the one ordered pair that works for both equations. Now we've been doing this on weekly assignments, but I simply asked, where do they intersect? The real question we are finding is what ordered pair is a solution for both? If I put that ordered pair here, does it equal equal? If I put the solution here, does it equal equal? What we want to do is, typically we would graph these, but sometimes you won't have enough graph paper. And do you really feel like getting a bigger piece? Or what if it doesn't cross at a nice whole number? Maybe it's somewhere in between. So what we're going to do is make sure both of these equations say y equals slope x plus intercept, and we're going to do some algebra from there. Well, if I take a look, this equation is set, y equals slope x plus intercept. Yes. This one is not, so I'm going to have to do some solving. The previous lesson talked about solving for y. Let's take a look and solve for y here quickly. So I'll recopy what I have. I need to get y all by itself. Add opposite of 6x to both sides. Negative 6x plus 6x is 0. I am left with 6y. On this side, I cannot add these. This has an x, this does not. The best I can do is rewrite them. Get rid of a multiplied 6. Multiply by the reciprocal. Here's the trick. If I do it to the left side, I must do it to the entire right side. How do I show I'm multiplying the entire right-hand side by 1/6? I need to put parentheses in. On the left, 1/6 times 6 reduces out. I'm left with y equals. On the right, I have to distribute. 1/6, 1/6. 1/6 times negative 6 is negative 1. 1/6 times negative 6 is negative 1. This had an x, so it still has an x. What is this as a linear equation in slope and then intercept form? Is negative 1x plus negative 1. Again, I could graph both of these, but I may not have enough room. So let's take a look at the algebra needed to solve for it. Okay, so here I am. I have my two equations. They're both now in linear equation form, slope, intercept form, the slope and the intercept. How do I know? Because y is all by itself. The bottom line is I must end up with an ordered pair. I must have an x answer and I must have a y answer. That's where I have to end up. So what I'm going to do is take a look at this and see if I can't fuse these two together and solve for x, and then I'll solve for y. So what I want to do is, can I take this and put them together? The answer is I can. I'm going to take this equation and I'm going to rewrite it down here. The thing I'm going to do is drop off the y. So I'm going to take this equation equals negative 5x plus negative 13. Now the reason I dropped off the y is because I want to replace the y with something else that y is equal to. It's called substituting variables. So can I find anywhere else on this board something else that says, oh, by the way, y equals this? Here it said y equals, but I'm using this, so I dropped off the y. Where else on the board does it say y equals? Now this is the big step you have to take. Y doesn't have to equal always a number. Y can equal a statement. Here it says y equals this. So what I'm going to do is drop this in for y. I'm allowed to because I want to know what y is, and guess what? Y equals this. So I'm going to bring this over and put negative 1x plus negative 1. This is a true statement. Okay, I did my substitution. That's what I did. I substituted y equals this. Now I have one variable to solve for. Now this should be somewhat easy. Now I can get x by itself. So you have to remember back how to solve equations with variables on both sides. Here's an x, there's an x, everywhere is an x. Try to get rid of the smaller of the two. This is not the smallest, this is. How do I get rid of a negative 5x? Add 5x. Negative 5x plus 5x is 0. I end up with negative 13. On this side, what is 5x plus negative 1x? It's 4x. And I have a negative 1. I'm close. Now I have two operations. I need to get rid of the added number. Add the opposite, which is 1 to both sides. Add 1. 1 plus negative 1 is 0. These cross off. I'm left with 4x. On this side, negative 13 plus 1 is negative 12. Almost done. This is going to be a lot more solving involved. Here's a multiplied 4. What's the reciprocal? 1/4. What's the reciprocal? 1/4. The 4's cross off. I'm left with x equals negative 12 times 1/4 is negative 3. Now let's keep in mind what we just did here. I took two equations, I fused them together with substitution. I solved for the only variable that's left with it, which is x. I worked down. What is the x number? Negative 3. Now look at my final answer. Where does the negative 3 go? Does it go in the first slot or the second slot? Hopefully you say first slot because it's an x. Go down here into my answer. Halfway done. I figured out what x is. All right, now actually the second step's a lot easier. Pause if you need to because I need to erase. That's the beauty of the internet. I need to know what y equals. No, I can't put this down here. I need a number. I need a single number. What I need is one of the equations. I don't care which one you pick. Which would you rather? This one or this one? Flip a coin. I'm going to pick this one. Y equals negative 1 times x plus negative 1. Can I substitute anything in? Do I know what y is? You know, I have equations, but do I have a number? No. Do I have a number for what x is? Say yes. Please say yes. Look, x is negative 3. So I'm going to rewrite my equation. Y equals negative 1 times, how much is x? Negative 3 plus negative 1. Okay, can I solve? Y equals, what's negative 1 times negative 3? 3. I still have plus negative 1. What is 3 plus negative 1? 2. What is y equal? 2. Where do these two lines intersect at? What point is a solution? What ordered pair is a solution for both? The answer, negative 3, 2. Okay, this is the long way, but you have to be able to solve for two equations using substitution in a system of equation. A system is two or more linear equations joined together. You could graph, but not all the time is graphing possible. Good luck. This is the ultimate combination of a lot of algebra skills. This is the last segment of our linear equations.